Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6. We present the history of oscilloscope. First generation oscilloscope was invented by a French physicist named Andrew Blondel, who built and presented the first electromechanical oscilloscope back in 1893. The first one is hand-drawn oscillograms. This process was first partially automated by Jules Francois Joubert. The earliest method of creating an image of a waveform was through a laborious and painstaking process of measuring the voltage or current of a spinning rotor at specific points around the axis of the rotor, and noting the measurement taken with a galvanometer. By slowly advances around the rotor, a general standing wave can be drawn on graphic paper by recording the degrees of rotation and the meter strength of each position. Next, automated paper-drawn oscillograph. The first automated oscillograph used as a galvanometer to move a pen across a scroll or drum of paper, capturing wave patterns onto a continuously moving scroll. Due to the relatively high frequency speed of the waveform compared to the slow reaction time of the mechanical components, the waveform image was not drawn directly but instead built up over a period of time. This device, known as the Hospitalian ondograph, was based on this method of wave-form measurement. It automatically charged a capacitor from each 100 wave and discharged the stored energy through a recording galvanometer.
After the automatic paper-drawn oscillogram, a photographic oscillograph is invented. It was proposed to permit direct measurement of waveform. It was necessary to the recording device to use a very low mass measurement system that can move with sufficient speed to match the motion of the actual wave being measured. This was done with the development of the moving coil oscillograph by William Duddell, which is modern time is also referred as mirror galvanometer. This reduced the measurement device to a small mirror that could move at high speed to match the waveform. To perform a waveform measurement, a photographic slide would be dropped past a window where the light beam emerged, or a continuous roll of motion picture film would be scrolled across the aperture to record the waveform over time. Although the measurements were much more precise than the built-up paper recorders, there was still room for improvement due to having to develop the exposed image before they could be examined. After that, in the 1920s, a tiny tilting mirror attached to a diaphragm at the apex of a horn provided good response, even up to 10 kHz. A time-based asynchronous was provided by a spinning mirror polygon and a collimate beam of light from an arc lamp project to the waveform onto the lab wall or a screen. Even earlier, audio applied to a diaphragm on the gas feed to a flame made the flame height vary, and a spinning mirror polygon gave an early glimpse of waveform. Moving paper oscillograph using UV-sensitive paper and advanced mirror galvanometer provide multi-channel recording in the mid-20th century. Frequency response was into at least the low audio range.
Okay, in this part, I will explain to you about the cathode rays inventions, cathode rays tube inventions, which is one of the elements that used in the earlier oscilloscope. Actually, the cathode rays tube developments triggered the inventions of the oscilloscopes. Without CRT, the oscilloscope will not be invented. So, in 19th century, the CRT usually used to demonstrate and explore the physics of electrons. The CRT oscilloscope begins as an experimental instruments invented by Carl Ferdinand Brown in late of 18th. So, what is exactly is cathode rays tube is a device that used to display the image to the screen. A cathode ray tube is a glass vacuum tube with a beams of electrons shot through known as electron rays, cathode rays. The electron gun is made of three components, which are cathode, anode, and the screen. The cathode is to emit the electron. The anode is to focus the electrons to form a beam, and the glass is the place where the beams hit and form the image. Since the beams is a negatively charged, it can be affected by magnets to bend the beam. If it is fast enough, the image will be displayed. So I have a little bit clip that can improve your knowledge about the oscilloscope. So enjoy.
Now here is an important point. If a spot is moved back and forth rapidly over the same path, our eyes will see a solid line instead of the moving spot. Let's see what happens when we vary the currents in all the deflecting coils simultaneously. When the crank is turned on this mechanical device, the varying currents in the vertical and horizontal coils are synchronized to show us how the spot is moved by a pulsating direct current. Likewise, with the same arrangement, we can change the direction of flow in the vertical deflecting coils to show how the spot is deflected by an alternating current.
All the CRTs that you used before have been replaced by the LED, LCD, and plasma and so on nowadays.
Alright, last but not least, the last part, which is digital oscilloscope in the history of oscilloscope with me, KHAIRUL ROSDI. So this is a picture of a digital oscilloscope built with a small monitor to display the signal and some buttons for users to configure the graph. Basically, digital oscilloscope stores and analyzes the signal in digital ways rather than the previous technique, the analog one. It was constructed by Nikola Tesla Instrument of Medicine, Wisconsin in United States of America. It is firstly invented with a low-speed analog to digital converter with 1 MHz and 12 bit, and after that it was developed with a high-speed analog to digital converter by Walter Licrow with 100 MHz and 8 bit specs. In 1980s, digital oscilloscope became prevalent because of the advanced rigor, storage, display and measurement which oscilloscope digital provides. It uses a fast analog to digital converter and memory chips to record and show digital representation of waveform. Also relies on effective use of the installed memory inside it and the trigger functions. If the memory of oscilloscope is too large but didn't have trigger functions as desired, user will be difficult to get the output as they want. Nowadays, due to the rise in PC's generation, the oscilloscope has been invented in a PC base, which becoming more common to consumers. As the oscilloscope captures the signal, it will transmit the data to the laptop and the signal will be displayed on laptop monitor. Thank you.